Okay, now another topic, types of redox reaction. There are different types of redox reaction. So what are these types? As you know, there are different types of reactions like combination reaction, decomposition reaction, displacement reaction, already you have got in class 10. So this combination reaction, decomposition reaction, displacement reaction, these are one example of redox reaction. I mean, a combination reaction may be one example of redox reaction. A decomposition reaction may be one example of redox reaction. Displacement reaction may be one example of redox reaction. So these are called the type of redox reaction. So number one, combination reaction. A combination reaction is a type of redox reaction. What type of reactions are called combination or addition reaction? When two substances combine to get a single product, then that type of reactions are called combination reaction. And that combination reaction may be one example of redox reaction. For example, suppose carbon, when combines with oxygen, it produces carbon dioxide. So this type of reactions are called combination reaction because carbon combines with oxygen to form a single product. And this type of reactions are called combination reaction. And in combination reaction, you don't get any side product, you will get single product. Now, how it becomes a redox reaction? To find out that, what is the charge of carbon here? This is a free element, and in the rule you have got, if the atom is in free state, then the oxidation number of element is considered as 0. I mean, here the oxidation number of carbon is 0. Oxygen, O2, this is also a free molecule, that is why the charge of oxygen is considered as 0 here. In compound, when oxygen produces some compound, then the charge of oxygen is considered as -2. In rule you have got, so that is why the charge of oxygen here -2. There are two oxygen atoms, that's why -2 into 2, I mean -4. So what will be the charge of carbon? Carbon will be +4 here. So this is a compound, that's why the charge of carbon is +4. And by considering X also you can find out the charge of carbon. Now here you have got, in the reactant, the oxidation state of carbon is 0, but in product the oxidation state of carbon is +4. I mean 0 is converted to +4. Positive charge increases, I mean loss of electron takes place. Loss of electron means oxidation. I mean here carbon undergo oxidation due to this loss of electron. Here oxygen is 0, but here oxygen is -2. So negative charge going on increasing, I mean gain of electron takes place. As you know, gain of electron means reduction. So here reduction takes place, I mean here oxygen undergo reduction, gain of electron takes place. So this combination reaction you have seen, someone undergo oxidation, someone undergo reduction. I mean this combination reaction may be one example of redox reaction. This is another example, magnesium when combines with nitrogen, it produces magnesium nitride. Its formula is Mg3N2. To balance it, you can put 3 here. So when magnesium combines with nitrogen, it produces magnesium nitride, and this is one example of combination reaction. Here it is free element, that's why charge is 0. This is free molecule, charge is 0. But here, when it produces Mg3N2, magnesium is an alkaline earth metal, so its charge is +2. +2 into 3, you can do like this. Magnesium is +2 into 3 plus nitrogen is suppose X. There are two nitrogen, that's why twice X equals 0. I mean twice X is equal -6. So X equal be -3. So here the charge of nitrogen is -3. So in this way you can find out the charge. Now here you have got magnesium 0 is converted to +2. I mean loss of electron takes place, oxidation. Nitrogen 0 is converted to -3, negative charge increases, I mean gain of electron, so nitrogen undergo reduction. So this combination reaction is one example of your redox reaction. So a combination reaction may be example of redox reaction. Another type of reaction which is called decomposition reaction. A decomposition reaction may be one example of redox. For example, this is one compound which is called potassium chlorate, KClO3. When you heat this compound, then the compound undergo decomposition and it produces potassium chloride and oxygen. To balance this reaction, you can put 2 here, 3, then the equation become balanced. This type of reactions are called decomposition reaction. When one substance undergo decomposition to produce 2 or more product, then this type of reactions are called decomposition reaction. And decomposition is opposite to combination. In combination, 2 substances combine to give single product, and in decomposition, single reactant gives 2 or more products. So this is completely opposite of combination reaction. Now, to find out whether it is redox or not, you find out the charge of all element. You know potassium is always +1, oxygen is always -2 in compound. So what will be the charge of chlorine? You can find out the charge of chlorine by considering as x. -2 into 3 minus 6. 6 minus 1, you will get +5 charge of chlorine. Here potassium is fixed, that is +1, so chlorine will be -1, and this is oxygen free molecule, here it is 0. Now you can see here oxygen is -2 and here oxygen is 0. -2 converted to 0, a negative going on decreasing, I mean loss of electron takes place, I mean oxygen undergo oxidation. And chlorine +5 is converted to -1, gain of electron takes place, I mean it undergo reduction. So this decomposition reaction is also one example of redox reaction. Here potassium charge is fixed +1, it do not undergo any change of oxidation number. Only chlorine and oxygen undergo changing in oxidation number. That's why oxygen undergo oxidation and chlorine undergo reduction. So a decomposition reaction may be one example of redox reaction. Now another type of redox reaction, number 3, displacement reaction. Displacement reaction. This is one example of displacement reaction. When zinc combines with copper sulfate, it produces zinc sulfate and copper. Here zinc free metal, so here charge is 0. This is called sulfate. You know sulfate always have -2 charge, that is why copper will be +2 here. Here sulfate is -2, so zinc will be +2, and here copper free element, that's why 0. So here zinc displaces the copper, that's why it produces zinc sulfate, and that is why this is one example of displacement reaction. Now you have got a change in oxidation number. Here zinc is 0, but here zinc is +2. I mean 0 is converted to +2, that means loss of 2 electron takes place, I mean zinc undergo oxidation. Here copper is +2 and here copper is 0, positive going on decreasing, I mean gain of 2 electron takes place, I mean copper undergo reduction. So this displacement reaction may be one example of redox reaction, I mean here both oxidation and reduction takes place. So these are the type of redox reaction. A combination reaction may be example of your redox. Decomposition reaction may be one example of redox. Displacement reaction may be one example of redox reaction. Now another type of reaction, which will be number 4, this is called disproportionation reaction. Disproportionation reaction. This is one reaction, hydrogen peroxide. In presence of light, hydrogen peroxide undergo decomposition and it produces water and oxygen. And that is why hydrogen peroxide is always stored under dark colored bottle, because in presence of light, hydrogen peroxide undergo decomposition to produce water and oxygen. This is one example of decomposition reaction also. But this reaction is specially called disproportionation. You will get why it is called disproportionation reaction. The name of this compound is called hydrogen peroxide. In rule we have got, in peroxide, the oxidation number of oxygen is considered as -1. Normally in compound, oxidation number of oxygen is -2. In peroxide it is considered as -1. And hydrogen is always plus 1. But this is water, it's a normal compound of oxygen. Here the oxidation number of oxygen is -2, hydrogen is +1. And this is oxygen free molecule, that's why here the charge of oxygen is 0. Now you have seen, here -1 oxygen is converted to 0. -1 is converted to 0 means loss of electron, loss of 1 electron takes place, negative charge going on decreasing, I mean oxidation takes place, I mean increase in oxidation number. -1 is converted to 0 means increase in oxidation number, increase in oxidation number means oxidation, loss of electron. And here -1 is converted to -2, when -1 converted to -2, decrease in oxidation number takes place, I mean gain of electron takes place, I mean this one undergo reduction. Now here you have seen, normally in redox reaction, one element undergo oxidation, another element undergo reduction. But in this reaction, one of the element, I mean oxygen, undergo both oxidation and reduction. This type of reaction in which one of the element undergo both oxidation and reduction, then this type of reactions are called disproportionation reaction. So this is one example of disproportionation reaction, and this is one example of redox also. So disproportionation means nothing, self-oxidation reduction. I mean one element undergo both oxidation and reduction. This type of reactions are called disproportionation reaction. This is another example. This is phosphorus. Phosphorus exists as P4. When it combines with base, it produces PH3, which is called phosphine. Product are like this. This reaction is also one example of redox reaction. This is a free molecule, only phosphorus present, that's why here charge is 0. Hydrogen, you know, +1 into 3 +3, so phosphorus will be -3. Here the phosphorus charge, if you want to find out, hydrogen is +1, phosphorus is x, oxygen is -2 into 2 equal -2. So x you will get as +1. I mean here the charge of phosphorus is +1. Oxygen is -2, hydrogen is +1. That's why oxygen hydrogen oxidation number is fixed here. No changing takes place. Only phosphorus undergo changing in oxidation number. Now here phosphorus is 0. Here phosphorus is +1. Increase in oxidation number, I mean it undergo oxidation. Here phosphorus 0. Here phosphorus is -3. I mean decrease in oxidation number takes place. I mean this one undergo reduction. So here also one of the element, I mean only phosphorus undergo both oxidation and reduction. I mean this is called self-oxidation reduction. So this is also one example of disproportionation reaction. In exam you may get the question like this: what is disproportionation reaction? Give one example. Then you have to write the example like this. So a disproportionation reaction may be one example of redox reaction.